root mean square RMS value of alternating current. The RMS, which stands for root mean square value of an alternating current AC, is defined as the equivalent value of direct current DC that would produce the same amount of heat in a resistor as the AC does over the same period of time. Now let's understand this definition. So here we can see on the left side this is a AC circuit and on right side it is a DC circuit. Here I of t is the current and it is equal to Im sin omega t. So this is a AC supply or AC current and this is resistor R. This is also resistor R, and now here the DC supply is given, the current through this is current I. Now let's say this heat, let's say the heat generated by this current I is 10 joule. Now this heat is also 10 joule. The value of this current is, let's say, 2 ampere. So the IRMS value of this AC current or alternating current will be 2 ampere. Again, this heat is 10 joule, let's say. Here also the same heat 10 joule. This DC current is 2 ampere. So the value of IRMS is 2 ampere. That means the RMS, that is root mean square value of an alternating current AC, is defined as the equivalent value of direct current. So it will be the equivalent value of direct current that would produce the same amount of heat in a resistor as the AC does over the same period of time. That means it will produce the same amount of heat for, let's say, 1 hour. So here also it will produce same amount of heat for 1 hour when its IRMS value will be 2 ampere, like this. So it is for understanding purpose. It may be any value. Now let's see the derivation of root mean square value. IRMS is equal to, now to remember this expression, first of all we will take the square. We will go in reverse order. First we will take the square, then mean, then root. So first of all let's take the square of I of t. Now we will take its mean. So it will be like this, integral from 0 to t dt, and it will be divided by t. Now we will take root. So root means to the power 1 by 2. We will take its power 1 by 2. Now if we solve this, we will get IRMS. So it is equal to, now we can write this as square bracket 1 upon t, then integral from 0 to t I of t square. So we know that I of t is Im sin omega t. Im sin omega t. So we have to take its square. So it will be square and this will be square. Then dt. Now its power 1 by 2. Now let's simplify this further. So it will be bracket 1 by t. Now this Im square is constant, so we can take this outside. So it will be Im square by t, integral from 0 to t. Now we have to take this sin square omega t dt. First we will write this as it is, sin square omega t dt. Now bracket close to the power 1 by 2. Now there is one formula for sine square theta. It is equal to 1 minus cos 2 theta divided by 2. It is equal to square bracket, then Im square divided by t. Now integral from 0 to t. Now in place of sine square omega t, we will put this formula. So it will be 1 minus cos 2. Now here the theta value is omega t. So 2 omega t divided by 2 dt. Bracket close to the power 1 by 2. Now here this 1 by 2, this 2 is constant, so we can take this outside. So let's copy this again. So if we take this 2 outside, so it will be like this. Now let's take the integration of this 1 minus cos 2 omega t. So it will be again square bracket Im square divided by 2t. Now integration of 1 will be t. Then minus integration of cos 2 omega t will be sine 2 omega t divided by 2 omega t, and its limit will be from here. Its limit will be from here is t. Now we will take the square bracket again, and its limit will be from 0 to t. 0 to t, and whole power will be 1 by 2. So it will be again square bracket Im square divided by 2t in bracket. Now this will be upper limit minus lower limit. So upper limit is t minus 0. Then minus, now here sine upper limit will be 2 omega t divided by 2 omega capital T. We have to replace this small t by capital T. Here there is a little mistake. So here it will be only 2 omega. Here also this will be 2 omega. Now this is correct. So upper limit is capital T, then lower limit is 0. So sine 2 0. So sine 0 will be 0. So we will skip this term, or let's write this for understanding purpose. Then to the whole power 1 by 2. So it is equal to again Im square divided by 2t. So this will be now in square bracket t, then minus sine 2t 2 omega t divided by omega. To the power 1 by 2. Now we know that omega is equal to 2 pi f, and f is equal to 1 upon t. So 2 pi by t. F is equal to 1 upon t. So omega is equal to 2 pi by t. Now here, if we take this t on this side, so it will be omega t is equal to 2 pi. omega t is equal to 2 pi. So here we can substitute omega t is equal to 2 pi. So let's put here, this is 2. Don't forget this 2. Now if we put this omega t is equal to 2 pi, so this will be this term will become 0. Let's solve this in calculator. Sin 2 into 180. Pi means 180 degree. So it will be 0. So this term will become 0. So again, let's copy this. Now this term will become 0. So we can erase this also. So we have to multiply this whole with only t. Now this t and this t will get cancelled. So what is remaining part? Only in bracket im square divided by 2. This t and this t will get cancelled, and to the power 1 by 2. So this 2 and this 2 will get cancelled. So only im divided by root 2, and this is all equal to IRMS. Now if we simplify this, 1 upon root 2, 1 divided by root 2. So it is 0.707. 0.707 im. So therefore IRMS is equal to 0.707 im, where im is the maximum value of current, of alternating current. Maximum value of alternating current. So this is the relationship between maximum value and RMS value in case of alternating current.